Hello and welcome to Geology. I am Robert Lopez, and today I want to talk about sedimentary rocks. Really starting off with this section in your book called Interlude B, which deals with weathering. And I'm going to focus mostly on weathering and not so much on the soils part here. And that sedimentary rocks are important for three reasons. First of all, they're conspicuous. They're a thin cover. They mantle just about everything on Earth's surface. If you look at the percentages, they only make up 8% of rocks on Earth's crust, whereas igneous and metamorphic rock are making the bulk, but nonetheless, they're up at the top. So that's the first reason they're important. So you'll run into sedimentary rocks wherever you go. The second reason they're important is that sedimentary rocks have fossils. Here I call them the archives of Earth history. So these fossils will record Earth's change through time and oceans change through time, atmospheres change through time, and life change through time. The other thing that sedimentary rocks record in structures, they give us clues to past environments of deposition. Was it a landslide? Was it a stream flowing? Was it a gentle lake? Was it a deep ocean environment? So the type of sedimentary rock we see is indicative of an environment of deposition. And finally, the third reason why sedimentary rocks are important is fossil fuels. Fossil fuels, coal, gas, petroleum, it's our way of life. When you flip that light switch on, the lights turn on, and what's really happening is somewhere we're burning coal or natural gas or even worse, nuclear energy. But all those are part of the sedimentary rocks. They're found in sedimentary rocks. Originate from fossil organisms, primarily planktonic organisms, and then migrate through pore spaces in sedimentary rocks. Now I want to cover some material here on the document camera in terms of weathering. And so kind of looking at this interlude B, we see that the word sediment refers to loose material, right? And this loose material can be fragments of rock, pieces of broken rock, broken minerals. We know that sediments also include dissolved ions in solution, so that dissolved material can precipitate. So minerals like halite is an example of a sediment. Gypsum, precipitating out of water. And also shells and shell fragments would be parts of sediment. And the next question I have here is, what does it take to make sedimentary rock? What does it take to make the sedimentary rock? And I always talk about this four-step process, although your book has fives, and what they do, they combine these to erosion and transportation, but really those are the same thing. So if we kind of focus in at this, let's look at this four-step process, only in that my exam will ask for the four-step process. So we're going to have some source rock. Right, and that source rock is going to be exposed to weathering, and we'll see that that's the first step. So weathering is number one. Weathering is number one of these four steps. And so you can think of weathering as a liberation of components. You're separating components from the source rock. So think of this as a separation. Is going to either mechanically break minerals or rock fragments from that source rock, so that'd be the physical weathering. You can think of that as a mechanical breakdown, or there could be chemicals like acid leaching or oxidation or hydrolysis. That's going to decompose or take pieces of the source rock, right? Take chemical elements away and break the rock down in that fashion. So really, we want to emphasize here that there's two types. There's two types of weathering, and the first one is this physical weathering, and the second one is the chemical weathering, right? So two types of weathering. But again, they're a separation of components, a liberation of components from the source rock. So that's the first step. The second step is this erosion transportation. Your book here breaks them into two different steps, so really it's the same thing. Your erosion means you're moving, right? So this basically means you're moving something, right? And well, it means the same thing, right? It means the same thing, moving something. And so what are some of the agents of transportation? Well, we have glaciers. A glacier can move material. Wind is another good agent of transportation. We have water. Water, and primarily in a system called a fluvial. And fluvial refers to a stream, a river stream, right? And then another important one is gravity. And gravity only because we're looking at rock falls, landslides, debris flows. Anything that's moving down slope is called mass wasting. So later on, maybe we'll get into a chapter on mass wasting. But anyways, those are some of the agents of transportation, right? The agents of transportation. But really, the erosion transportation is really the same thing, moving material. Now, at some point, this material is going to come to rest somewhere, right? So think of this as its resting place, and this resting place will be the third step in the four-step process up here, right? And so it's going to come to rest in some environment. Either it's going to be in a terrestrial environment. Usually these are non-marine, which means land, continental. Sometimes we call it continental, but mostly we call it terrestrial. And then, or you could have a transitional coastal environment, like a marsh, an estuary, the beach zone, the beach system. Deltas is another one that's a coastal. Or the marine environment, right? And the marine, you will see we have a variety of regions of the marine. There could be the shelf, right? Continental shelf, something called the slope. You could be in something called the rise, or in some areas where there's active margins, you can have a trench, or you can be in the abyss, right? Or abyssal plains. So the deep parts, the deep flat parts of the ocean. So there's a variety of marine environments, and that's just physically, but there's also climate zones, right, where there's tropics and temperate regions and glacial regions. So this can vary even in the independent physical regions, right? But anyway, so after number 3, this is the key thing is anything that's forming here, it's deposited, it's resting, right? It's still sediment, right? It's still sediment, which means it's loose. It's unconsolidated. In fact, let's look at the PowerPoint here. There was an interesting slide here that your book has. And so here, this bedrock is consolidated. It's a rock now. And something had to happen to the sediment that made that rock. Whereas here, this is said to be unconsolidated sediment. So this is not a rock. Something has to happen to this sediment before it forms a rock. And what that process is our 4th step over here, number 4. And that 4th step is the lithification process. So remember, lith is a Greek word which means stone. So basically the stone forming process, right? And that process takes 3 steps. And I want you to know these 3 steps. First one is burial. So your book doesn't really mention burial, but you have to bury this stuff, right? You have to, and that burial leads to overburden compression, and eventually the sediment gets squeezed together. The pore spaces decrease, the grains shift closer together, and so that's called compaction. So your book does talk about compaction. And then finally, we know that there's groundwater and water that's percolating through the sediments. Hard water is the word I'm looking for. So sometimes they call this hard water, and the hard water is leaving mineral deposits in these small little pore spaces. And so before you can glue that sediment together, make that sediment rock, you need the cement. So we call that cementation. So the 3 steps for lithification is there's burial, compaction, cementation. And then finally, only then can you make a sedimentary rock. And your book kind of breaks them out a little bit differently than I do. There's the first group is siliciclastic rocks, like sandstones is a good example of this one. And I'll mention more about, remember, clastic is broken, right? Broken in Greek. Silice refers to silicate minerals. So these are silicate minerals that are busted up, broken, and they're making rocks like sandstones, mudstones, shales, right? But then all these other ones are kind of a group that I kind of lump together as biochemical or chemical rocks. And so yeah, biochemical rocks are formed from shells of organisms, right? So you can think of these as the hard body parts organisms. Primarily shells, right? Some shells have a slightly different chemical composition, right? Some will have slightly different chemical compositions. When you look at organic rock, we're mostly looking at coal. So coal, the compressed portions of plants, or in some cases, it's the organic material of the once living organisms. So the hard body parts make the biochemical rocks, but their guts and internal organs are making organic rock, right, which is rich in organic carbon, coal, or and eventually it could even make petroleum, right? And then for the chemical rock, these are going to be sort of like travertine. Travertine is a good example, or when you can make rock salt is another good example. When water evaporates, you can make rock salt. So those are some examples of these chemical rocks.